नमस्कार दोस्तों। क्या आपको पता है मशीन लर्निंग जगत का द मोस्ट पावरफुल, द मोस्ट इंट्यूटिव, द मोस्ट रोबस्ट एल्गोरिदम कौन सा है? डिसीजन ट्री। और वो क्या चीज़ है जो डिसीजन ट्री को इतना रोबस्ट बनाती है? उसका है ट्री लाइक स्ट्रक्चर। क्या आपने कभी गौर किया है, जब भी आप अमेजॉन, फ्लिपकार्ट जैसी ई कॉमर्स वेबसाइट प्रोडक्ट्स खरीदना चाहते हो, तो वे ई कॉमर्स वेबसाइट आपको नीचे प्रोडक्ट की रिकमेंडेशन देती है, और ये वही प्रोडक्ट्स होते हैं जो आपको या तो पसंद हो या आपने पहले कभी बाय किया हो। तो ये सब कैसे करते हैं, कैसे प्रोडक्ट रिकमेंडेशंस देते हैं, इसी के पीछे के मैथ्स को, इसी के पीछे के एल्गोरिदम को मैं आज आपके सामने लेकर आया हूँ डिसीजन ट्री का पूरा वीडियो। सो लेट्स डाइव डीप इनटू द सी ऑफ एल्गोरिदम। Hi guys, welcome. As you saw my introduction video, I was telling you about the decision tree. Okay, so what do you mean by tree models? So what are tree models? So in machine learning, a tree model is a type of predictive model that uses a tree-like structure to make decision. As I already told you in the introduction video, it splits data into branches based on feature values leading to outcomes at the leaves. So I will tell you what leaves is subsequently. So in this module, you will be learning about two important machine learning models. So the first one is decision tree and the second one is random forest. We will be first learning decision tree, then random forest, then we will see what an ensemble is. So basically ensemble is a collection of multiple models. So with high interpretability and intuitive algorithm, decision trees mimic the human decision making process. So decision trees mimic human decision making process. You must have studied the algorithms such as logistic regression, support vector machines. So decision tree do not help in finding any kind of linear relationship, right? What we have studied in machine learning algorithm, that there are certain points we are trying to construct a line, and this is a training data set and the test data set, right? So this was how we used to do in machine learning algorithm, that is linear regression. So here in decision tree, we don't want any kind of linear relationship. So you can use decision tree to explain all factors that led to a particular decision or prediction, and so can be used in explaining certain business decisions to entrepreneurs. Decision tree form the building blocks for random forest, which are commonly used among Kaggle community. So you must be knowing about Kaggle community. What is it? So basically, it's a global platform where data scientists, machine learning engineers, and AI enthusiasts come together to, solve real world problems, compete for prizes, predicting, new data for projects, sharing and exploring codes, doing courses, interacting with each other in a discussion forums, etc., etc. So this is very valuable. Okay, so there is, you can find hands-on learning with real data, exposure to cutting edge techniques, opportunity to build portfolio and gain visibility. Okay, so random forest are the most efficient machine learning models. So I will be teaching all of these, and by the end of this module you should be able to use decision trees and random forest to solve both classification and regression problems. So we will be doing both classification and regression problems. You have seen classical machine learning algorithm like linear regression. We have already discussed logistic regression for solving both regression and classification problems. Then what do you think is the need of going ahead with these models? Okay. So linear models not able to handle multicollinearity. It is not able to handle non-linear relationship. So here comes the role of decision tree, which leverages on these properties. So you will learn about each of these in details as you go ahead. So let me once again reiterate the definition of decision tree. As the name suggests, it's a tree-like model to make predictions. It resembles an upside down tree. Okay, it's like this upside down tree. This is the main trunk. So it uses similar process that you do to make decisions in real life, just like humans do, by asking a series of questions to arrive at a decision, right? So a decision tree splits data into multiple sets of data. Each of these sets is then further split into subsets. Okay. So here you will find subsets. Let us understand this with an example. Okay. So let's say a person is having headache. So what he will do, he will go to doctor and doctor will check him. First doctor will go for blood pressure checking, right? Then if it is yes, there can be two possibilities. If the patient has BP, then he will go for ECG. And if the result of BP is no, then the doctor will check for fever. Okay, this is how it goes. If he is diagnosed with fever, then either he must be having viral. If no, then doctor will prescribe some painkillers and he will go home. And if he is having viral, there will be two conditions. He will go for treatment or else doctor will prescribe painkiller. So as you saw in this video, a decision tree uses a natural decision making process. That is, it asks a series of questions in a nested if then else statement on each node. So this is the node. On each node you ask a question to further split the data, that is how you have a node. If the test passes, you move to the left, otherwise you move to the right. Okay. Now this first node is called as root node. This is called as root node. These are internal nodes. These are all internal nodes. And the node that cannot be further classified means these, right? These are all leaf nodes. Okay. So this is how it works. Let us do one question. Netflix is looking to recommend premium membership to some of its existing members. Let us take down this question. Netflix is going to distribute premium membership. So let us draw the tree structure. So this is old membership greater than 1 year. Here is the gender and here is average hours spent per day greater than 2. So greater than 2 hours, if somebody is spending, then we have to look for the splitting. And if there is gender, then the splitting will be on male and female. So we have male, we have female. So what is male doing? Number of violations on account sharing policy. If it is less than 2, 2 to 10 and greater than 10. Recommend premium, do not recommend premium. And if there is a female, then always go for recommend premium. So even if the old membership is not greater than 1, then also there is a provision of Netflix giving out recommending premium plans, and if there are certain type of most watched content, then go for recommendation of premium. So this is how this question. So we have to predict the class level. So what is class level? The labels which are associated with leaf nodes are called class labels. So let's consider case 1. If the membership period is greater than 1, gender is male, and number of violation is less than 2, then what will be the recommendation? So greater than 1, gender is male, and number of violation is less than 2. So it will recommend premium. So this is how the thinking goes. So as you saw in this explanation, it is easy to interpret a decision tree, and you can almost always identify various factors that led to a particular decision, right? In fact, trees are often underestimated in their ability to relate the predictor variables to their predictions. So as a rule of thumb, if interpretability by a layman is required, so if some layman is there, so as a rule of thumb, if interpretability by layman is what you are looking for in a model, then decision tree should be at the top of your list. So as you saw in the video, you start from top, that is root node, traverse left to right according to result of the condition. Each new condition adds to previous condition with logical and you may continue to traverse further until you reach final condition as leaf node. So in a decision tree, each decision is reached via path that can be expressed as a series of if and logical and are the two conditions that has to be satisfied together. Now let us understand how we can construct the decision tree. So there are 6 steps which is required. So step number 1 is recursive binary splitting. So what do you mean by recursive binary splitting? At every node there are 2 splits. That is why it is binary, and it is taking place repeatedly. That is why recursive. Selecting the best rule from a variable or attribute for split. Attribute for split. What is the best attribute which can lead to best split? So this is also we have to take care in while designing or constructing a decision tree. Third step is applying the split based on rules obtained from attributes. So whatever rules is obtained from attributes, we have to apply the split. Fourth is repeating the process for the subsets obtained. Fifth is continuing the process until the stopping criterion is reached. So we have to continue this process till we get stopping criterion. And the final step will be assigning the majority, class or average value as prediction. So class labels. So this can be class or it can be average. So this is in case of decision tree regressor. This is in case of decision tree classification. So you might be having many questions lingering on your mind, like what is the best variable for split and how do I know what's the stopping criteria and so on. In coming session, you will be learning each of these processing details. Now you have somewhat understood that the decision tree building process is a top-down approach. Okay, so the top-down approach refers to the process of starting from top with the whole data and gradually splitting the data into smaller subsets. And we call this decision tree process as greedy approach also. So why greedy? Because it does not take into account what will happen in the next 2 or 3 steps. Okay, so it takes care only about current step and not takes into account what will happen in next 2-3 steps. The entire structure of tree changes with small variation in the input data. Okay, this in turn changes the way you split and the final decisions together. This means that the process is not holistic in nature as it only aims to gain an immediate result. So gaining of immediate result that is derived after splitting the data at a particular node based on certain rule of attribute. That is why this process is called as greedy approach. Greedy approach. So now let's start with building decision tree on Python. So before starting, we need to have certain libraries. So I just mentioned the name of those libraries. Okay. So pandas, numpy, these are common libraries. matplotlib.pyplot, cbon, then you need to have sklearn, ipython, string.io, graphviz. So these are the different libraries that are required for decision tree for building on Python. Okay. So let's start with the video now.
So hi guys, welcome. So we will be doing all the Python coding in Google Colab. This is the coding interface. As I told you, we will be importing all the necessary libraries first. So as you can see, I have imported all the general common libraries. Import numpy as mp, import pandas as pd, import matplotlib.pyplot as plt, import cbon as sns. Pandas and numpy, these are used for data manipulation and numerical operations. Matplotlib and cbon are used for plotting and visualization. I have this heart underscore v2.csv. This is my data. So now what I have to do, I have to read this CSV file into a data frame. Okay.
So heart underscore v2.csv file has to be uploaded to this Google Colab. Okay, using a set of Python codes. So let us write those codes. From Google Colab, import files, uploaded equals files dot upload. Okay. So once I execute this command, I'll get the option of choose files. So this is how I'm getting the option of choose files. So I'll go to downloads, decision tree seminars, and I'll locate heart underscore v2. To read a CSV file, let us consider df as the data frame, pd dot read underscore csv, heart underscore v2 dot csv. Now let us try to display the first 5 lines of the data frame. So this is the first 5 rows of the data frame: age, sex, blood pressure, cholesterol, heart disease.
So heart disease are in terms of zeros and ones. So ones means the person has heart disease and zero means the person is not having heart disease. Okay. And these are different parameters, their age, what is the sex, whether the person is male or female. So 1 is male, 0 is female. BP, these are the blood pressure counts. So you can check the columns. These are the columns. So after the display of the data frame, the first step which I'll be taking is feature and target suppression. So feature and target suppression. Okay, so this is the first step. So from DF, I drop this heart disease to get X. It means from this data frame, the heart disease column will be separated and the balance columns with the data, it will be stored in X. So our X will be having 1, 2, 3, 4 columns, age, sex, BP and cholesterol. I'll put X is equals 1 because I need to have on those columns. What will be Y? This will be Y. Now let us check what are X and Y. So X dot head, or we can have X dot shape. So you can see here there are 270 rows and 4 columns. And X dot head also we can check. So see, we have these 4 columns. We don't have Y. Y dot shape, only 1 column. Y dot here we have this heart disease zeros and ones, only 1 column. Now after we have separated X and Y's, let us start with train test split. So train test split. So I have to import the model from sklearn.model selection, import train test split. So I'll be having 4 variables: X train, X test, and Y train and Y test. Okay, X train, X test, Y train, Y test. So how do we assign the values? X comma Y comma, we have train size equals 0.7. It means out of this total X, it will be divided into 2 parts, X train and X test. So X train will carry 70% of the total data set, and we will have random state equals random 42. You can take any value. So now that we will have model training with decision tree. Okay. So we need to import decision tree classifier. Then we have to initialize the decision tree with maximum depth of 3. It means that there will be 3 levels of the tree. This is ensured to prevent overfitting and make visualization easier. So dt, let's take this variable dt. So this we have taken max depth equals 3. And now after this, we will fit the X train and Y train into this decision tree. So now the X train and Y train are fitted in decision tree. So the model has been fitted on the training data. Now let us go for visualization. So we will be using different library as discussed earlier. So from ipython.display, I'll be importing the image module from 6. So string IO is imported from 6 library. This will create in-memory file object. The export graphviz module is imported from sklearn tree. So export graphviz is a function that converts a trained decision tree model into graphviz dot format. Okay, so it will convert into graphviz dot format, which is a plain text graph description language. Okay, so this dot data can then be used to visualize the decision tree. So that is why this export graphviz is used. And we will be importing this library graphviz. And so we have dot underscore data is equal to string IO. So we are going to plot the tree with max depth equals 3. So export underscore graphviz, inside bracket we'll have, then we have out file, out underscore file equals, so out underscore file will be our dot data, this one, dot underscore data. Filled equals true, rounded equals true. So these are the general characteristics of graph. Now the most important thing will be to put feature names. So what are our feature names? So feature names will be whatever we have X, all these. So X dot columns, that will be our feature names. And what will be our class names? So class names will be our Y. So what is Y? Whether the patient is having disease or no disease. So class names equals disease comma no disease. So from dot data we will be taking the different points. It will take all the values and it will transfer to the graph. So you can see here using export graph viz and different parameters we have got this decision tree. So it says if age is less than or equal to 54.5, okay, there are so many samples. So if it is true, I mean the age is true, then you have different parameters which is to be subsetted. So now we will come on sex. If sex is less than or equal to 5, it means less than 0.5 is female, more than 0.5 is male. So here female, yes, and the cholesterol level is less than 300. So here the class will be no disease. If sex is greater, then it will move to this branch. Here there is another bifurcation of age. If age is less than or equal to 40.5, yes, and this is no. So here the person will have disease, and here the person will not have any disease. So for evaluating the model performance, we have to see the accuracy score. So accuracy score will be in respect of y actual versus y predicted. So there will be two parts, train and test. So y train versus y train pred and y test versus y test pred. So how to predict? I'll write this code. So how we are calculating y train predicted? So this is dt, that is decision tree, and we have to predict over x train. Similarly, y test spread, we have to predict over x test. Execute it. So we will be importing two evaluation parameter, that is confusion matrix and accuracy score. Execute it. So now we will print accuracy score of y train comma y train pred. Accuracy score which we are getting is 0.74. So this model is good. Similarly, we will find out confusion matrix. So the confusion matrix is 82, 19, 30, 58. Similarly, we will calculate accuracy score of y test and y test spread and confusion matrix. So we are getting the accuracy score of 0.60. That is lower than what we have achieved in train data.
So guys, you have seen the accuracy score of train data and test data. So with the explanation stated earlier, the accuracy score of test data is lesser than the train data. So before discussing as to how we can improve the accuracy score of test data, let me explain the codes which are very crucial in creating the decision tree structure. So here you can see from ipython.display import image. So this imports the image class from ipython library, which allows you to display images directly in Jupyter notebooks. It is useful for showing visual outputs like decision tree diagrams. Okay. Now what is 6 import string IO? From 6 import string IO, what we actually are doing? String IO is a class, okay, that creates an in-memory file like object. It behaves like a file but stores data in memory. String IO is used here to temporarily hold the dot format data. Okay. Now the next command is from sklearn.tree import export graphviz, export underscore graphviz. So this function from scikit-learn, so sklearn is basically scikit-learn. This function is used to convert a trained decision tree model into dot format, which is a plain text graph description image. So dot format is readable by tools like GraphViz and PyDotPlus to generate visualization. So here PyDotPlus, it is a Python interface to GraphViz.language. It can parse dot data and generate graph objects. GraphViz is a package that can also render dot files, though in this code PyDotPlus is doing the rendering. So now let us try to understand this code. Dot data is equal to string IO. So basically it converts the dot data format string stored in dot underscore data into a graph object using PyDotPlus. Okay. Now export underscore graphviz, it converts the trained decision model. So what was our decision model? That was dt. So we had used dt equals decision tree classifier, and we have kept the hyperparameter as max. underscore depth equals 3. So this was our model having only one hyperparameter. So I'll tell you what hyperparameters is subsequently. So it converts the train decision model dt into dot format, which is a plain text graph description image. What is out file equals dot underscore data? It writes the dot data into dot underscore data stream created earlier using string IO. Okay. Filled equals true. It fills the node with colors to indicate the majority class and class distribution. Rounded equals true means it gives the nodes round corners for better visual appeal. Feature underscore name equals x dot columns. It uses the actual column names from whatever is your data set x to label the decision nodes. So basically this is for labeling decision node. And finally, what is class names, class underscore names? So these labels the output classes for better interpretability. This command converts the dot format string into a graph object using py.plus, and this command converts the graph into a PNG image and displays it directly in the notebook using IPython's image class. So this is how you can write the code having similar classification options. I hope this gets well into your head. Now one more thing I would like you to concentrate here is Gini. So here you can see Gini is 0.49. What do you mean by Gini? What is Gini coefficient? And what is the use of Gini in decision tree model? So Gini is also called as Gini Index, also called as Gini Impurity. Okay. So Gini impurity is basically a matrix which is used to determine how much pure the node is. It also helps the algorithm to decide on which feature to split on at each step of the decision tree. So Gini impurity measures the probability that a randomly chosen element from the set would be incorrectly classified if it was randomly labeled according to distribution of labels in the node. So a Gini of 0 means the node is pure, and if the Gini is approaching to 1, then the node is mixed. So the classification is mixed. So it has got more impurity or mixed class. So during tree construction, the algorithm looks for splits that reduce the Gini impurity to the most. So Gini impurity will be reduced as the algorithm goes forward. Now coming back to how we can improve the accuracy score of the model. So you can see that the model that we have now is not performing well. Why? Because the accuracy score of test dataset was lesser than the training dataset. This is because we build our model on the default parameters except for the depth. Okay, so what we did only with one parameter, one hyperparameter, that is max depth, max underscore depth equals 3. We didn't change any other hyperparameters. So there are other hyperparameters also here.
So I'll be telling you what are hyperparameters and what do you understand by hyperparameter tuning. Okay. So as I told you, there are other hyperparameters also. So let me explain what an hyperparameter is. Hyperparameters are simply the parameters that we pass on to the learning algorithm to control the training of the model. Hyperparameters are choices that the algorithm designer makes to tune the behavior of the learning algorithm. The choice of the hyperparameters therefore has a lot of bearing on the final model produced by the learning algorithms. So basically anything that is passed on to the algorithm before it begins its training or learning process is a hyperparameter. These are the parameters that the user provides and not something that the algorithm learns on its own during the training process. So here one of the hyperparameters that you saw was max depth, right, which we put 3. It essentially determines how many levels of nodes will you have from the root to leaf number of nodes. This is something that the algorithm is incapable of determining on its own and has to be provided by the user. Hence it is a hyperparameter. Now obviously, since hyperparameters can take many values, it is essential for us to determine the optimal values where the model will perform the best. So this is something called as optimal values of hyperparameters. This process of optimizing hyperparameters is called hyperparameter tuning. So this you will be learning in the next sessions subsequent. So guys, now you know what is decision tree, how to construct decision tree using set of commands on Python, what is hyperparameter, what is hyperparameter tuning. So now you saw a very general model of decision tree. So by changing hyperparameters and to tune the behavior of tree model, we can even construct better tree models. So stay tuned for the video. Thank you.